Hello, good morning everyone. So I'm presenting Bosch Industrial Boilers. My name is Heiko Engelhardt and I want to start with a short video about Bosch Industrial because all of you know Bosch about household appliances, about power tools, about the automobile industry. But I show you the video, what we are doing, what our drive is to reduce CO2 emissions and energy savings in the heavy industry. Okay, so we are in the heavy industry, yeah. Our products, our boilers are used for food, for beverage, for construction, in all kind of businesses, yeah. Paper, clothes, consuming an extensive amount of energy. At this moment, the energy is gas, oil, or a mixture of both. So where is the future going to? And what is in today for you? We have a global increased demand of industrial steam amount or production heat amount. I'll show you something about that. We have an increasing global demand on industry itself, also goods, because the population is growing. That's a matter of fact. And we are going into or pushing into CO2 neutral solutions, yeah, with our products for our customers. And yeah, global acting companies like, so we call it the key accounts, Nestle, Mars, Unilever, Procter & Gamble, etc. They are already going this way. They want to be CO2 neutral in 2030, sorry. So, starting with the facts that the population and the global energy consumption will increase in future. Yeah? We have a table here, a sketch of showing the population of the world will increase consistently to until 2050. Whereas the energy consumption will also increase because of you need more food, you need more beverages, you have a higher standard of living. So my energy consumption will increase. That's a fact. And on this last slide, you see the energy consumption according to the fuels. And here you see an interesting fact. Fossil fuels and gas, natural gas and oil will grow a little bit, but it is a or we can see a downstream on this demand replaced by CO2 neutral fuels. So when starting a project, start a project to be CO2 neutral or starting to get into CO2 neutrality, I have basically two options. First of all, my old existing, or let's say existing plant to optimize with energy sufficient solutions. The higher my efficiency of my plant is, the lower my fuel consumption is. And we believe 20 to 30% of the nowadays used energy in the world can be saved by using the right technologies, which are available. The future, the future is use of alternative fuels. Alternative fuels nowadays are available, but in very little and short amounts. And it only makes sense if these fuels are produced green, also with green energy, and then they call it carbon neutral. Genau. What are alternative fuels? Or what is the reason or the main drive or the main character an alternative fuel must be? First of all, it must be available. Yeah? I don't need to plan a plant for H2 firing if I don't have H2 available. I come to this later. It must be ecological. That means no make sense to produce these fuels with a high amount of energy, like electric energy or even hydrogen. But there are different hydrogen levels I show you in the next slide. It must be economical, of course, otherwise, it does not make sense it will increase all the price of all products, etc. A certain amount is accepted by the population or by the customer, but this has always limits. And last but not least, it must be storable. Yeah. So hydrogen. Hydrogen is now in everyone's mind as the fuel of the future. What is hydrogen? Hydrogen is the smallest atom in the world, and it has the ability to diffuse two metals. So this is a burden at the moment. Special materials needed for hydrogen. The flame temperature to burn hydrogen is about 2000 degrees centigrade. And it is about 3 times less heating value in hydrogen than in natural gas. So the consumption will be 3 times more to have the same amount of energy or heat. We have several ways, or there are several ways to produce hydrogen. One is called the blue hydrogen and the other green hydrogen. What is the difference? Green hydrogen is CO2 neutral. That means it is produced by using energy from wind or solar power, and without using electric energy from the grid, from the power plants, etc. This is real green hydrogen. Then we have something in between. You call it turquoise hydrogen. It's made by methane pyrolysis with energy from the grid, also from the public network or from the power plants. And gray, this is a bad hydrogen. It's made by electrolysis with electric energy from power plants. Could be coal, could be nuclear, whatever. Definitely, you need energy, a lot of energy to produce hydrogen at this moment. And the question is, where does the energy to produce the hydrogen comes from? Is this energy green or not? The big benefit of hydrogen in any case is it's storable. Yeah? This is the biggest benefit of it, because electricity to store is quite difficult at the moment. You need big storages, you need large amount of batteries, which are also not so environmental to produce. So, overview. Motivation. What is the motivation to use H2 as fuel? Yeah. Again, if it's available, it's a very quick solution to be CO2 neutral. With my existing boiler, the existing boilers can be transferred or transformed to burn or to handle CO2. Yeah? It's not a matter of the technology, it's just a matter of availability. Also fast and quick solution which is available. It is transportable. This is also a benefit. Yeah. In the meantime, or nowadays, the gas network is not capable for H2. Meaning, in Europe or in Germany, in the German network for natural gas, there is already 10 to 15% H2 in this network, but that's the maximum at the moment. So the complete network must be built to be capable for H2. And this is not a short-term, this is a long-term solution. You know, again, a slide about the drive or the benefit of green energy, green H2. It should come either from sun or from wind or from any other source which we don't know yet. Heat pumps, geothermic heat from the ground, from the soil. So then water is divided in O2 and H2. We have H2 in gasoline form available. This can be burnt into for the boiler, for the process heat, for heating. And it can be also transferred into electricity again. Now you ask, does it make sense first to put energy in, to produce H2, and then with fuel cells, you produce electricity again? This is only for storage reasons, transportable, localization reasons. What alternatives we have to the hydrogen solution? Well, what is available at the moment? Let's say this. We have a hydrogen finished product on the market, can run 100% on hydrogen. This is a conventional boiler with a special firing system, as a combustion system, made for hydrogen. Okay? Hydrogen ready is if a customer nowadays is investing money and he knows in the future, I want to be on hydrogen. He can put in, or he can buy a hydrogen ready boiler. And when hydrogen is available in 10 years, he only changes the burner side, the combustion side, and he runs on H2 and is CO2 neutral. This is an example of a company in Switzerland. It's a pharma concern, and they use 20-ton boilers running on 100% hydrogen already. They have the benefit that the hydrogen is produced in a plant next to, and it's a side product of their process. So the benefit is also it's close, it's available, and it's kind of affordable. Plus, for production security, the boiler is also equipped still with a natural gas line. This is a plant we have in Germany. This plant is a wood producing or processing plant. They do wood chips, they do decor woods, and they have their own energy supply or central. They use turbines. With the turbines, they produce electric energy. With the electric energy, they make H2. The H2 they use again for combustion, for firing. Also, you see they are available. Now, my time is running out. Now you ask the question, why producing H2? Using a lot of electric energy to do that, why not putting that direct into the boiler to produce steam or process heat with electric energy? And this is our latest, or let's say since 2 years, our most asked product. It is an electric steam boiler, directly electrical heated up to a capacity of 7.5 tons with a connection load of 5.5 megawatt. Does this make sense? Yes, it does, if the electricity comes from natural resources, from green energy, windcraft, solar power. And that is a direct use of the electric energy produced into the process heat. So at the moment, this is the most feasible solution for a customer who wants to go CO2 neutral. Then we have a combination of both. This is a conventional boiler with a conventional burner and a heating element, electric heating element. That means the boiler can run on both fuels. Both fuels support each other. So if think about, you have photovoltaic PV on the roofs during the daytime. My photovoltaic is supporting the boiler. It's free energy. It comes from the sun. It's green. During the night, or if there is cloudy sky or rainy, like it is at the moment, this burner can supply the boiler or can supply the consumer for the customer or at the customer with the necessary process heat. Also available, also possible with H2. And then we are again complete CO2 neutral. Next topic is biofuels. Biofuels are around since long time. Wastewater treatment is a very good resource for biofuels. Biofuels can be fired completely, let's say, without any additional engineering or any additional costs. Biofuels are most of the cases free of charge, available. And I take the example for breweries, big breweries, they have their wastewater treatment. Wastewater treatment produces biogas, and they use the biogas for their heating or for their process heat. This is an example of a biogas boiler. In Denmark is somehow very, very into CO2 neutrality in general. And I would say in Europe, they are the first ones, using CO2 neutral gas or fuels. So, last slide. What we learned today, or what you can take away, is CO2 neutral boilers available with hydrogen, biogas, or a mixture of both. Hybrid boilers, which is a combination of electric and fuel. If the fuel, no matter what, comes from natural, also from green, it is CO2 neutral. And last but not least, the electrical boilers, which run on 100% electricity. One more. Thank you.